The universe is a grandiose structure that consists of an infinite number of very diverse objects. They are separated by such vast cosmic spaces that even light is lost in their depths. After all, in order to reach the nearest stars, a photon leaving the Sun will need more than 4 years. And overcoming intergalactic distances will take millions of years. The realization that this gigantic path is only a tiny step on the scale of the macrocosmos cannot but amaze the imagination. So how big is the universe really? The solar system is only one of countless planetary systems in our galaxy. It includes a single main sequence star, as well as 8 planets with their satellites. In addition, the system contains more than 1 million small celestial bodies such as asteroids, comets, and meteorites. The most distant planet from the solar system currently known is Neptune. Its orbital radius is about 30 astronomical units, which is equivalent to about 4 light hours. Surprisingly, only a small part of the solar system lies within the orbit of Neptune. Its most distant object discovered is called Far Far Out. Currently located at a distance of 132 astronomical units from the Sun, which corresponds to 18 light hours. However, even this celestial body, barely noticeable against the background of the cosmic abyss, is far from the hypothetical Oort cloud. Its internal boundaries lie approximately 2,000 astronomical units from the center of our system. And the outer ones, according to some estimates, extend to at least 60,000 astronomical units, which is about 1 light year. These boundaries are determined by the limits of the gravitational influence of our Sun, and beyond them lies interstellar space. If we continue to move further, we will find that there are more than 50 different luminaries within 20 light-years of the Sun. From faint and cool brown dwarfs, to bright and well-known objects such as Sirius, Procyon, or Altair. Some of them have their own planetary systems, in which one can find celestial bodies potentially suitable for the origin and development of life. For example, an object called Gliese 832c, located about 16.1 light-years from the Sun, is more Earth-like than any planet in the solar system. The average surface temperature of the exoplanet reaches 253 K or -20 degrees Celsius, and for a complete revolution around the mother star it takes only 36 Earth days. By the standards of the universe, the distance from us to Gliese 832c is considered relatively small. However, a spacecraft leaving our system at a speed of about 17 km per second will take about 300,000 years to reach the vicinity of the exoplanet. At the present stage of technology development, it is not yet possible to build an interstellar ship capable of withstanding such a long journey. The solar system, along with its stellar neighbors, is part of the Orion Arm, which in turn is part of the Milky Way galaxy. It contains about 400 billion stars in its vicinity, of which it is estimated that more than 1 trillion exoplanets of many different types could be discovered. The main diameter of the Milky Way is about 100,000 light-years, and the size of the stellar one can reach twice that size. The thickness of the main disk is approximately 1,000 light-years, but there is a noticeable thickening in the center of the galaxy. It is called the bulge and has a lateral dimension of about 3,000 light-years. The Milky Way is part of the so-called local group of galaxies. This is a vast structure that includes more than 50 galaxies, concentrated in a region of space with a diameter of about 10 million light-years. Andromeda, Triangle, and Milky Way are the largest of them. The total mass of the cluster, according to some estimates, may be close to 3 trillion solar, with most of it accounting for our galaxy and the Andromeda Nebula. Earth is separated from it by about 2.5 million light-years, so Andromeda is considered the closest galaxy to us, excluding dwarf ones. The local group, in turn, is part of the giant Virgo supercluster, which consists of more than 30,000 galaxies located in a region of space with a diameter of about 150 million light-years. Its total mass reaches about 1 quadrillion solar, which corresponds to about 1,000 galaxies such as the Milky Way. The supercluster has a flattened shape, about 60% of all objects included in its composition can be represented as a flat sheet about 10 million light-years thick. This value seems huge, but in terms of the large-scale structure of the universe it is quite small. Gradually moving away, we will be able to see a giant supercluster of galaxies measuring about 520 million light-years. It is called Laniakea, and includes several galactic superclusters, including the Virgo supercluster, as well as a great attractor. Moreover, the total mass of the formation exceeds the solar one by about 100 quadrillion times. The great attractor, located approximately 250 million light-years from our planet, is the center of gravity for all nearby objects. It is impossible to directly observe it from the ground, since the plane of the Milky Way interferes with the instruments. For this reason, the essence of the great attractor still remains an unresolved mystery of nature. Laniakea is part of the large-scale structure of the universe. Complex systems of galactic filaments, walls, and views, gigantic regions of cosmic emptiness. Some of these objects are truly unimaginable in size. For example, the Great Wall of Hercules, the northern corona, stretches over a distance of about 10 billion light-years. Since its discovery in 2013, this superstructure has been considered the most gigantic component of the large-scale structure of the universe. It contains, in all likelihood, millions of galaxies, and the exact number of luminaries included in their composition is most likely impossible to calculate. The very existence of such a structure is a mystery to science, because according to the currently accepted theory of the evolution of the universe, the formation of such gigantic clusters is simply impossible. However, this wall, which the human mind cannot imagine in its full grandeur, occupies only a small fraction of the visible part of the universe. According to modern cosmological ideas of space, our universe is constantly expanding, and the speed of this expansion depends on the distance between objects. The further the observed object is located from the observer, the faster the distance between them increases. Moreover, this distance is limited by the speed of light, since the fabric of space itself is expanding, which means that at a certain distance objects will become mutually invisible. Observations of the cosmic microwave background radiation show that the observable region of the universe is a sphere with a diameter of about 93 billion light-years. According to the theory of relativity, we can only see and interact with those objects that are inside it. This area of space is called a metagalaxy, and it can be either the entire universe or a small part of it. Hypothetically, structures unknown to us may be located outside the visible region of outer space. Such entities are called extraintergalactic objects, and, unfortunately, it is currently impossible to study them using scientific methods. However, some astronomical objects at the boundary visible to the universe are not moving as they should, according to available data. Such cases of anomalous motion can serve as evidence that the presence of some massive structures outside the metagalaxy cannot be ruled out. Their attraction permeates the surrounding space, influencing surrounding objects. There are many hypotheses about the structure of the universe outside the metagalaxy, but most of them are rather metaphysical in nature. For example, there is a point of view according to which outside the boundaries of the universe there is no time and space in our usual understanding. The physical laws we know do not apply, and concepts such as matter, substance, or energy turn into nonsense. A logical development of this hypothesis is the idea that the metagalaxy is only part of an even more complex and large-scale cosmic superstructure, a structure and dimensions that we, in principle, are not able to imagine. It is likely that it may be located in a multidimensional space or be based on physical principles unknown to us. The metagalaxy is thus only a minor detail or partial reflection of this incredible superstructure. Some interpretations of the anthropic principle suggest the existence of other worlds beyond the visible universe, with other values of fundamental constants, such as the speed of light or the charge of an electron. Closely related to this hypothesis is the idea of a multiverse, which can be represented as a kind of foam, consisting of many bubbles separated by thin but insurmountable partitions. Thus, each universe is a separate space with its own physical laws, perhaps radically different from those to which we are accustomed. The most radical hypotheses completely deny our world objective reality. According to this assumption, the universe is just a simulation similar to computer virtual reality, of an incredibly high level. As a rule, such ideas assume the existence, outside of our usual reality, of some kind of superbeing or supercivilization, the level of development of which is much higher than ours. Their goals and capabilities are probably mysterious and incomprehensible, but it is most likely impossible to prove or disprove such hypotheses. Of course, cosmic distances amaze the imagination and even frighten. From the point of view of a modern person, they seem endless. It is only known that at the moment our universe is expanding. If this process continues, then the moment will come when space objects, one after another, will disappear beyond the event horizon. First the galaxies, and then the stars, thereby immersing the world in an eternal theme. However, no one will see this anymore.